Hello. Okay. Yes, guys, welcome to our today's session. We are going to move forward, and today we are going to talk about chapter 9. Remember, the last one was chapter 8, but I wrote chapter 7. So now we are going to talk about chapter 9, right? It's very easy, straightforward. And after chapter 9, you must get ready to write your final examinations. And guys, remember that you need 85% as per now up to your final Ccna 3. So what we are going to do today, it's like a very easy lesson, but you have just to be careful, and the configuration is very straightforward. So what we are going to do today, the whole idea of this today's lesson is this. Suppose, guys, you got your company, right? Or you got your computers. Your computer is connected to switches, and those switches are connected to one router, right? You got only one router. What's going to happen if that router fails, right? What's going to happen? So if that router failed, right? Like you're at home, or maybe you got a small office or a small company with few offices, you got a wireless access point. So all those computers are connected to the switches, and switches are connected to wireless access point, and that wireless access point is allowing your users, like in your company, to be connected to the internet. What's going to happen? So if that wireless access point, that wireless router failed, right? So the whole network will be down. So the users cannot go to the internet, the connections will be a problem, right? Now, you as a specialist, you as a Cisco engineer, you need to come up with a plan. When you are designing a network, you must always come up with a plan. You must always ask, what's going to happen? So if my two switches are connected, right? So if that link fails, what to do? You have to know that you can configure the Ether channel. What's going to happen? So if my switches are connected to this router, what's going to happen? So if this router is down, what can I do? What are the techniques must I use in order to do what? To create a way to keep my users connected, right? So today's lesson, we will discuss how you can make a plan when your router failed. So if there is a problem on your router, users must still be connected. So we're gonna see how you can have two routers, and those routers will behave as one router, right? You got multiple routers, but those multiple routers can behave as one router, right? In order, if one of the router failed, users can still access using that other router, right? So this whole lesson for today, it's how to combine routers in order to create one virtual router, right? So, and users, they can still using the virtual router, but they will think like they are using the physical ones, but actually they are using the logical router. So we got physical routers, we are going to create a logical router, right? So, and users will be connected to that logical router. Why? Because we want redundancy. We want to avoid problems. If there is a problem in one of the router, our data must still, our users must still be connected. This is the whole lesson for today. So I'm going to try to share my screen, and we are going to move forward, right? Yeah. So we are going to talk about Fhrp redundancy protocol, right? Fhrp redundancy protocol, right? So the whole idea of this Fhrp redundancy protocol, you can also call it FSRP, like in short, right? The whole idea is what? It's combining physical router in order to create one logical, right? So we are going to combine the physical routers in order to create a logical one. So, and that logical one, it's a virtual one. Right? So this is the whole idea, right? Right? Why we have why? We need to combine physical routers in order to create one logical, because if one of the physical router failed, users can still be connected. So it's gonna be like this. I'm gonna try like to do something here. So you can have here maybe one computer here. There's another PC here. Those PCs are connected to one of the switch here, right? This is right, and your switch will be connected to router 1, and your switch will be connected again to router 2, right? So you're gonna have what? Router 1 and router 2. So this switch will be connected to 2 routers, right? Physical routers. Now you as a specialist, you have to configure those 2 routers to behave as one, right? You have to configure those 2 routers to behave as one, right? Those 2 must behave like one, right? If this router 1 failed, right? Users can still access the network by using what? By using this part, right? They can still go like this, right? This is the whole idea, right? Now, what you have to understand is this. When we're talking about this Fhrp redundancy protocol, we're talking about a family of protocols. Family of protocols or computer programs, right? Or network computer programs, right? So this is a family of protocols or computer programs. It means, again, it means different type flavors or different types of fast hop redundancy protocol. So we do have different types of this protocol, right? This fast hop redundancy protocol, right? Different types, but we're gonna use the 3 types, the 3 main ones, right? So we do have 3 types of them, right? As I said, we do have 3 types. Let me try first to stop sharing. So guys, you can see what we're talking about, right? You got 2 routers, 2 wireless access points that are connected to your network. So if one wireless access point, because the wireless access point is also a router, if that router fails, users can still access the network using that other router. Now that method, that technique, that will allow us to combine physical routers in order to create one logical, we call it fast hop redundancy protocol. Redundancy means multiple, right? This is fast hop redundancy protocol, FHRP, right? This is what we are going to be doing. Now, that protocol, the first hop redundancy protocol, is not only one protocol. It's not only one computer program. It's a family of computer programs. There are different flavors. There are different types of those FHRP, right? And we're going to talk about 3 of them, right? So there are 3 different ones, right? Now, the first one is what we call the host, the HSRP host standby redundancy protocol. This is the first one. The second one, we have the VVRP. This is the virtual yes, the virtual root redundancy protocol. And the last one, it's so I'm gonna just write it down. Gateway gateway load balancing. Right. I'm gonna try to reduce a bit in order for me to have them in a single what I can do like this. Okay, those are the 3 that we do have, right? The HSRP, VVRP, and the GLBP, right? Which card can I pick up? I'm looking at nice one. Okay, so those are the different types. So means what? Means that you can create virtual routers by going to one of these protocols, right? Let me try to stop sharing. So guys, you wanna combine your physical routers in order to create one logical. There are 3 ways. There are 3 types of computer programs or protocols you can use, right? But the whole technique is called first hop redundancy protocol. But that first hop redundancy protocol comes in 3 different types or 3 different computer programs, right? One of them is called what? HSRP, host standby redundancy protocol. So you can go for what's HSRP. Somebody else can go for VRRP, virtual router redundancy protocol, or you can go for gateway load balancing redundancy protocol. So there are 3 types, right? And you have to know how those 3 types operate, but they are working like almost the same way, right? I'm checking somebody. Okay, I'm gonna try to share again my screen. Yeah. Now we're gonna start with the first one, right? How this one works. The host standby redundancy protocol, right? This one will work like this. You're gonna have like, this is your switch, right? Switch one, you're gonna have maybe your computer there, computer one. Computer two. Now you're gonna have like two routers. Router one and router two, right? I'm explaining how this HSRP works, right? What's gonna happen, right? This R1 will be considered like an active router, right? This is gonna be the active router, maybe. So one of the router must be your active. That is what I'm saying. Right? So this one will be your standby. All right? This is how this works. To standby. So when you go for HRP, host standby redundancy protocol, one router must be your active and another router will be your standby. What does it mean by active and standby? So active and standby means if the active one fails, the standby router will take over, right? So this is how you have to configure. But how to proceed? How this HSRP works, right? Because these two computers, this one and this one, will require like a default gateway, right? These two PC will require the default gateway, but you will notice like you got two routers, means two default gateways. What to do now, right? What you're gonna do, right? You are going to have a virtual IP and a virtual MAC address, right? So for these two routers, you are going to create what? Virtual IP and a virtual MAC address, right? So these two computers, right? Default gateway will be what? The default gateway of this computer. So it's gonna be what? This virtual IP, right? So the default gateway for this computer is gonna be this virtual IP, and the default gateway for this one is gonna be the same virtual IP. So for this method, host standby redundancy protocol, those two routers will have like its own virtual IP and virtual MAC address, right? And this router that you considered like active will take the ownership, right? So this, the standby one will have just wait, right? Active router takes the ownership. Standby router waits for something to happen. to happen to router 1, to active router. So in order to take over, right? So the active router is the one that's gonna take like the ownership. So, and the standby router will have to do what? To wait, just to observe how the communication happens. So if there is a problem on an active router, the standby router will take over, right? But the question is how to select the active router between routers. This is the main question, right? How to select the active router between routers, right? This is the main question, how to select the active router, right? What do you think, guys? How we can select? Right? How to select it, guys? 1 minute. So you're gonna have like two routers. Which one will be selected as the active router? All right. For the router to be selected as like an active router, we're gonna check what? The highest priority, right? We have to check the highest priority, right? So the router that will have like a highest priority is the router that's gonna be selected as an active router, right? So guys, we're talking about the first method, host, right? Host standby redundancy protocol. You have two routers. Those two routers, they're gonna have what? Their own IPs, and computers will have also what? Two default gateways for those two routers. But how one computer can use two default gateways? That's impossible, right? Now, you have to combine those two physical routers, those two IPs, to create one logical, to create one virtual IP, one logical IP. And those two routers will have their own MAC addresses, right? You have also to create what? Virtual MAC address, right? So those computers, they won't gonna use any more multiple default gateways. Those two default gateways, they're gonna use which one? Virtual one, the logical one. But how to select the logical one, right? The logical one will be selected by checking the priority, the highest priority, because those routers will have the priority that you can configure, right? The highest priority will be chosen like what? Like active. This is how the selection happens, right? Now, you see how those two routers, guys, will work. You have router 1 and router 2, right? Those routers will start sending what we call the hello message to host down here, to devices, right? Just to show them that they're active, they are working, right? When they will start sending those messages, right? So for every 3 seconds, after 3 seconds, those two routers will send what we call like hello message, right? Just to let those other computers like aware like they are working, right? So router number 2 will have to wait, right? like 10 seconds, we call it the hold time, right? For 10 seconds, router number 2 will start observing what happened with router number 1. If for 10 seconds, router number 1 doesn't send a hello message, so there is nothing, there's no communication, router 2, the standby router, will know that there is a problem on router number 1. Let me take over. Right? So what you have to understand is this: you got two routers, the active router and the standby router. The active router will start like communicating with others. Every 3 seconds, the active router will start sending the hello message using a multicast message. Multicast message is a message that will be sent to a group of hosts. So router number 1, the active router, will start sending for every 3 seconds like a message to others, just for letting them know like I'm active, right? Now, suppose like there's a problem, right? The standby router will use 10 seconds for observing what's going on with router number 1. So if there is no activities on router number 1 between those 10 seconds, when those 10 seconds will expire, the observation time will expire, so router number 2, the standby, will understand that it has been already like 10 seconds. Why there is no hello message? Why there is no action on router number 1? Means there is a problem. Let me take over. This is the whole idea, and you have to remember that for host standby redundancy, a protocol, one router will be the active and another one will be the standard, not the standby. And those two, they have to use a logical IP and logical MAC address. How you're gonna get that logical IP? The logical IP will come by selecting the one that will have the highest priority between those two routers, right? Now, the multicast message that will come, that multicast message will come in 2 versions, because when you are talking to other devices, you are using a multicast like IP. That multicast IP will come in 2 versions. There's version 1 and version 2, right? Let me try to write it for you. Multicast messages sent by the active, sent by routers, will have 2 versions. Version 1, the IP .0.0.2, and version 2. Right? So router number 1 will start sending what? The hello message, right? Like a message to other hosts, right? Like every 3 seconds, every 3 seconds, just to let you know that I'm alive, right? So for me to send those messages, I can use a multicast message. Multicast message means it's one of the messages that I'm sending to everybody at the same time. So I can use version 1 or version 2. When I'm using version 1, means I'm using which IP? This IP. When I'm going for version 2, means I'm using this IP address. So the IP that I'm gonna use for sending, like when you're on a ping, when you put like version 1, like IP, right? So you're sending to everybody, but using version 1, right? Now, we're gonna talk about now the format of what? Format of virtual MAC address, right? The format that we're gonna have for version 1, when you go for version 1, this is the format that your MAC address will have, right? And when you go for version 2, FX or C9F. So you have to know those two formats for the exam, right? So those are the format of what? Virtual MAC addresses. For version 1, and this one is for version 2. And these two here, this 2, and this 3 here, for version 3, this is what we call what? The group ID. This is the group ID. This is the group ID also, right? Oh, a copy here. Yeah, because routers will belong to a specific group, right? That group is gonna have like a group ID, right? And you're gonna notice it from the MAC address, because MAC address will be created like automatically, right? But you have to know how to identify your group ID for version 1 and how to identify your group ID for version 2, right? I think, yeah. So now we're gonna go for the second one, the second method, this one. Virtual router redundancy. Let me take the last one first, because the last one and the first one use the same techniques, right? When you go for this one too, is the same principle for this gateway load balancing protocol. So router number 1 gonna still be your what? Your active router. Router number 2 gonna still be your standby, right? So this one it's almost like the same as what? This one, right? But the gateway load balancing protocol will use different MAC addresses, right? We'll use different one, not the same one. Not like a single virtual one, right? So this is the whole idea, right? This is the whole virtual, yeah. So guys, so as I said, you got your two routers. You want to configure the first hop redundancy protocol, but by using the Fhrp, that's first method, that first protocol, host standby redundancy protocol. What you have to understand is this: you need logical IP or virtual IP and virtual MAC address, right? So those two routers, one will be your active routers and one will be your standby, right? And your active router will start like talking to hosts. For every second, you're gonna be one of the message, the hello message. We call it a multicast message, a message that's gonna be sent to all those other hosts, just to let them know like I'm on, right? Now, suppose like there's a problem, right? Router number 2, the one that's gonna be considered as your standby router, the one that's gonna be waiting, that router will start watching what happened in router 1 for 10 seconds. We called it hold time, the time of holding, of waiting. After those 10 seconds, if there's still not an activities on router number 1, the active router, the router number 2 will understand like there's a problem and will take over, right? And remember that routers will start like sending the hello message using a multicast IP. There's an IP address that we call it a multicast IP. So if router one want to talk to host, router number one will use an IP address for multicast. So an IP address that will allow your router to talk to everybody at the same time. Now that IP address can use version 1 or version 2. Version 1, the IP is 224.0.0.2. Version 2 is 224.0.0.102. You must know that. And we do have the format of MAC addresses. When you go for version 1, it's a format, and you must know which one is the group ID. The last two, right? So it's going to identify your group ID, right? So when you have a MAC address, that's virtual MAC address, you must know how to pick up your group ID. Look at the two last digits, or if they are letters, or letter plus number, when you go for version 1, and look at those last three when you go for version 2. Now, there's a second method that we call the gateway load balancing protocol. But remember that the gateway load balancing protocol and even the host standby redundancy protocol, they belong to Cisco. They are Cisco proprietary, Cisco protocols. So Cisco came up with those protocols. But for global or for gateway load balancing protocol, there is a problem, right? Those computers, right? Those routers, they are going to use what? The computers are going to use their own virtual MAC addresses, not as like on the previous one. The previous one, the host, the Fhrp, they are using same MAC address. But for global, we're going to use different virtual MAC addresses. All right. I'm going to share. All right. My internet is a bit bad. I cannot. All right. Now, beside that one, there's also what we call the second one. We're gonna go for, where is it? The second method, yeah, this one. Now we're gonna talk about the virtual, right? Right. Virtual. Why did I do it? Okay. Yeah. Now we're gonna talk about this virtual, right? Sorry. One router will be your master router. That other one will be your backup router, right? So one router will be your master, so another one will be your master, right? So this is the main difference, right? One router will be your master and one router will be your backup, right? And the selection for you to select your master router, see what you're gonna do. So for master router, right? Master router must have what? Same IP as the virtual router. So your master router will have the same IP as your virtual router, right? Master router will have the same router, same IP as your virtual router, right? Now, there's what we call what? The ownership, right? So this master router will be what we call the ownership or the owner, right? So when you assign this master router same IP as the virtual router, master router will be considered as the owner, all right? Now we're gonna go from the configurations, right?
Hi guys, how are you? How are you, sir? Guys, if you're using the canteen, obviously during
So
our
guys,
our times are different, right?
what we're gonna do now,
Remember,
right?
call center, right?
I'm gonna go to the configurations, show you how to configure it, right? I'm gonna just take one of the example here. So I can have here maybe 2 computers, like here maybe 2 other computers. I can try maybe having 1 switch, and then I can have another switch. I can have maybe one router there and another one here. Let me check if I got port. I don't like this router. Let me take the 29 and I can remove this one. I don't want maybe these 2 computers from now. So I'm just doing this. Now we're gonna have maybe this one, gigabit 0/1. I can connect to any 0/1. I can connect there. Right? And we can console to the suite, to the router. You can console also here. Right? And my IP address I'm gonna give to this interface is gonna be 192.168.1.3, and this one is gonna be 192.168.1.2. My virtual IP is gonna be 192.168.1.1, and I'm gonna go for host standby redundancy protocol, right? So what I'm gonna do, we need to bring this interface on, right? I'm gonna go to my computer here, desktop, terminal. Okay, you can do the same with me, guys. Right, my interface is gigabit 0/0. Let me check it again. Yes, no shutdown. My IP address, remember what I've said, it's gonna be 192.168.1, 168.1.2, my subnet mask .0, right? So, and now I can configure my standby, right? This is, I can tell this router which one is the virtual IP. So I can say like standby, you can press tab, right? Just to complete for you. And guys, you can press like the question mark when you wanna learn more about what's gonna come like after the standby, right? Now, after standby, you can pick up like an ID, like a number, maybe standby 10, or I can say maybe standby 20, followed by the IP address, right? So I'm creating like a group ID. My IP address is 192.168.1.1 for the virtual one, right? And I'm done. I can do show run or do show copy run because I want to copy. Do show copy run start. Why it doesn't work? Okay. I can say do write just for saving. Okay. When I'm done, we can go to the next router. We're gonna do the same thing. All right. You go to terminal. No. It's conft. What is my interface? Interface gigabit 0/0. IP address 192.168.1.3, 255.255.255.0. When I'm done, I'm gonna say standby 20, my group ID, my IP 192, my virtual IP .1.1, and I can say do, right? Okay, when I'm done, oh, that interface, yes, it was not on. No shutdown. Let me check if maybe my configuration. I'm just checking if it's already there. Do show run. If my virtual, okay, fine. Now, what I'm gonna do, you go to every computer, you assign it an IP 1.1.10, and you give it a virtual one, all right? And on this one too, 192.168.1.11, 192.168.1.1, and we can ping that other one, ping 192.168. Maybe I can ping first the virtual one. You can see the communication. So I can try also to ping that other computer. There is a communication, right? So this is how you can configure, right? If this one is down, the communication gonna still happen, right? So guys, I'm gonna just give you like an exercise that you can practice for me, please. Just for me to make sure that you understood what I've explained. All right. So I have here one router. This router will have like a PC here. There's gonna be another PC here, right? This router will be connected to two routers. And we're gonna have another switch here. That's gonna be connected to another computer. This one to another computer, and this switch too will be connected to the same router. Router 1, router 2. You're gonna need different virtual IP here, because you got this site and For those other sites also, they're gonna have their own what? Virtual IP. So guys, we can practice, right? So thank you very much.